Welcome everybody. So this is just a quick tutorial just to show how we can create or use a chain that we can download from website and inject it through RBD simulation and have it accurately or somehow accurately simulate and respond to the forces appropriately. So in this demonstration, let me stop it. This is the one I'm controlling. Here there is an object I'm controlling, so I'm moving it down so the whole chain respond to it, and it's hitting the ground. Then I move it up and stretch it through the X like this. So there's these RBD objects in between, and also I use constraint between each one of these. Yes, so let's go how we. So as you can see here, funny. So it followed the movement of that piece. It went up. Then I need to increase the step of the simulation. Then it fall down here. Boom. So it is disconnected and it falls down. Or maybe the movement is very fast. Very fast. And it falls down. Boom. So this one was successful. So this is successful one. Okay, so this piece is moving. It doesn't account for rapid sudden movement, so it's following, and when we go down it go down. If I have more frame it will show more. Okay, so it is stretching, because with the glue, even if I make it -1 to an extent, it will just snap and break from here. And hard, same thing, it will not account for this rotation movement also. So I found the soft one is the suitable constraint for this. So enough of that. This is the simulation. It was successful. This is the static object that we are deforming and animating, and it's accepting the rotation. See, when we remove the active as 0, the last link was considered in the simulation. Yeah, see, it's more stable than the decomposition. Yeah, look nice. So many applications you can do with this one. I will share the HIP file so you can improve on it. I know it will. There's a better idea and better solution, but this is the thing that I managed to come up with. Not all went with this simulation. So before I start, I downloaded the chain from CG Trade. This is the OBJ file. 1, 2, 3, 4, 5 links. I just downloaded it as OBJ file. Then I went here and I imported it, and I give it a material of which material I give? I give you oxidized steel. That's the standard material. Then I transform it to this side. Let's put the grid and remove this one. Now I want to instance it and copy it a couple of times. So first thing I did, I just move it to the side. Okay, and here I move it again like this, so these two can align, and now they are merged. So you can do it like this way, or you can do a copy and transform. So I took these two connected line because this one ending horizontal and this one begin vertical. So when I make another copy, they will align perfectly like this. See? And I made 8 copies. I make long chain. After that, I merge it all together, and then, because if you look here, what I have on the attribute, I have only the position, and only I have here the path. So it's just the same information, nothing useful here. So what I did, I assembled them, I give them a name attribute, and I connect it inside. But what I'm interested in is the name attribute. So each link has its own name. So you can view it by pressing on I and press on name. Press on I, press on the name attribute. Maybe I need to activate it here. Yes, it's activated. This one, not this one. I need to remove this one, the texture. So if I go here one step before, no color for the name attribute. Here you have the visualization. So each chain has its own color. That means it has its own. So all these polygons refer to one link. So if you go down, see different. 100 unique name we have. Okay, so that's the first part. I use pen. I was trying to use pen to lock this one, but I did something else. It's not needed. I was experimenting. Then I move it up in the y-axis, like 15 degree. Then I blast and I lift this piece because I want it to be static, deforming static. I want to animate this one. So delete non-selected, and here I just copy and paste, and this is the remaining of the chain. This one will be included in the RBD simulation. Okay, so I just made some movement. Go down and go to the side. Let's add something else, like just move it up. Just for a change, let's move it up. And if you go here, I will rotate. So I have this movement, and then I will move it more on this axis. Make it like a 90 degree, and then go down. Okay, so we'll see what will happen. Anyway, now, so this part is done. Now this part, because this is Control G. If you can, as you can see, this geometry has a hole inside it. So convex shape won't work with it. Okay, concave also won't work with it. Decomposition, if you write decomposition, let's take this one, Control G. See, when you convex decomposition, see, it's a closed one. Convex segment. You can try segment geometry. We will try it. Okay, just leave it here because the approach I went with was completely different. Anyway, so what I did, I went with, because I remember we have the spheres. Okay, so I converted it to VDB. So we have a VDB now, surface. Then I convert it to spheres because I want each sphere or cube or anything that you can instance also. each sphere to be its own RBD object, but be treated inside the solver. Where's the solver? Inside the solver as one entity. Okay, so I went with crazy numbers so they can at least touch each other. Then I convert it back to polygon. 60,000. Then if you look here, when I convert, I don't have name attribute. I have name attribute, but it's useless. It's just the surface. So I wanted to take the name attribute that we did previously here. I want to copy it to here. Okay, so attribute transfer here. Okay, so I copy the name attribute in the primitive, so each sphere will be treated as one link. Okay, what did I do here? Yeah, I made it active because I was making this one inactive, and this one is easier. Then what I did, I went here and I created a constraint. These constraints, I made them very large according to the name attribute. So in each name one unit, one link. So each chain piece will be linked to the one beside it. Okay, and center of mass. What if let's go here. Let's go here. I want to view it. It's showing up just now. Control G. Let's say 20. Piece attribute should be name. Okay. So this is the link. Let me go down to 2. Okay, sorry, 2. What if I make it not center of mass, because center of mass is here. If I make it hang constraint, let's give it time. 1 second. Yeah, I just error it out into the surface point. So the surface point, as you can see, between each pieces. So if I went down to search radius, I make it smaller. Let's go up till we fill up one. So it's using a lot of constraint. That's why I went with center of mass. Okay. After that, I went here and I configured this. Give it a name. Tag. This constraint. It's called connector. I made it not glue, not hard. I make it soft, so we have little bit of movement, and I increase the stiffness with trial and error. So I send this to the RBD solver here. The solver collision concave for that piece and deforming. So I will sim it. Well, before I sim it, what I did after it's finished, I added point deform. The point deform, the first part is mesh to deform, and that's the original link that we have here. Okay. Second part is the rest point. I made a rest before the simulation here. Just add a rest node, so it will copy the original transformation of the V. and here the points I use the one coming from the RBD. Okay, so let me unchain this one and have a look. I will save it, I'll come back when it's done. Okay, I'll make the background by pressing D and make it dark and remove the background. Okay, in a second. So as you can see here, funny, so it followed the movement of that piece. It went up, then I need to increase the step of the simulation, then it fall down here, boom, so it is disconnected and it fall down. Or maybe the movement is very fast, very fast, and it fall down, boom. Anyway, so let's try to figure out what we can do. Okay, forget here, let's go to the where here, Control G. Let's see how it is moving. Okay, again, let's have a reference. So it's going up, it's going up. Here, see, here it moves fast. So what I will do, I will take these and move them. What I did here, look, is stop the simulation. I want this one, clear the simulation, control and then click, reset. Anyway, it's cache. We can remove the cache from this one. Where is it? The cache manager. Clear all. Here. Anyway, so I'm here. So I want to move these. I press shift, left click, I select them. Now the way I move, by middle click, I move them all the way. Again, I choose this one, left click, middle click, then I move here. Let's have a look again how it's moving. So I'm not happy with this movement. It's fast, so I'll just delete it and see what will happen. So we went all the, so let me send this again, and I will include it in the merge here. Let's merge it. Merge. This one and this one. So they are both together here. Really? I stopped the simulation. Okay, I will sim it and come back again. Let me remove this one. Simulation. So this one was successful. So this is successful one. Okay, so this piece is moving. It doesn't account for rapid sudden movement, so it's following, and when we go down, it go down. If I have more frame, it will show more. Okay, so it is stretching, because with the glue, even if I make it -1 to an extent, it will just snap and break from here. And hard, same thing, it will not account for this rotation movement also. So I found the soft one is the suitable constraint for this. So enough of that. See, let's go. Yeah. Excellent. Now I will try the decomposition with the different setting that we use, and let's see if it's working nice. Okay, stop. Let's go here and let's play with the convex decomposition as a segment geometry. Okay, I will add it to the blast node here of this constraint, Okay, I will connect it, and let's see here, do we have the name attribute? I have line 0 line, so I have lines. Okay, so I will link it. Don't need the attribute transfer. Maybe this attribute name segment attribute segment. So this is name link. Okay, so here I will just link it directly here, and the proxy here, and let's have a look. Okay, give it a second, and I'll change the animation here. Okay, so I'll Control Shift and click, left click will remove all the animation. So Alt and left click. So I'm having the transformation, translation and rotation keyed. So let's go to this frame, and I will move it in this direction, and I want to rotate it little and take it to the front and rotate like this. Okay, so is it fast? Yes, it's fast. So let's drag it, and I'll go to this frame. I want to take it all the way here and continue the rotation, take it down, and let's go all the way to the end. The end, and just take it here and here and rotate it like this. Okay, so let's find out if this one will work. Okay, so I'll just go down all the way here and see if it will work. I'll just take this side. Look how ugly it is. Maybe I need to play a little bit with this one. So anyway, I'll just take it from here and look up, because the name attributes already messed up, but I want to see if it will work or not. Okay, in a second. So as you can see, it didn't work. See, it already snapped here. So I don't think it is appropriate solution. But let us same the one we used here. Where did I connect it? Attribute create. Ah, sorry. This one I put it here, and this one I put it here. What I did here, the value 0 active for this link, the last one, so it don't move. So let me bypass it and see how it will move. Okay, and let's go to the merge, and we'll sim again in a second. So this is the simulation. It was successful. This is the static object that we are deforming and animating, and it's accepting the rotation. See, when we remove the active as 0, the last link was considered in the simulation. Yeah, see, it's more stable than the decomposition. Yeah, look nice. So many applications you can do with this one. I will share the HIP file so you can improve on it. I know it will, there's a better idea and better solution, but this is the thing that I managed to come up with. All, not all by me, not telling that I am the inventor of this method. A lot of tutorial I was watching on YouTube and Vimeo. So many artists and talent people pointed this method out. So I just wanted to share it with the community with a HIP file also. So thank you for watching. Have a nice day.